Math club's going to San Diego, looking at the ocean's tide. It is periodical with a 1/2 of a lunar day period. So 12 hours and 24 minutes is the period. First thing you want to do with that is change that 24 minutes out of 60, get 0.4. 12.4 is the period. We need period in part of our equation. We're going to use that to find B. Period equals 2 pi divided by B. And we're going to solve for B so we can have that in our equation. So multiply by B, divide by 12.4, you get B is 2 pi over 12.4. Kind of weird just to reduce it this way, but this is the way I like to do it. 12.4 can be divided by 2 pretty easily, so reduce this to just pi over 6.2. It's the most convenient way. You could change it into, like, I think it's 5 over 31, or I don't know, something like that, but just pi over 6.2 is fine. So, first full day of our trip, we found that the tide occurs for the first time, high tide occurs at 6:18. So we've got high tide, we've got low tide, and then we've got like the midline, the average. High tide happens at 6:18. Again, we want 18 minutes as a decimal, so 18 over 60 is 0.3. So 6.3 is when high tide happens. We measure the depth of the water, and it's 13 feet. At 12:42, which, doing some math there, that's 6 hours and 24 minutes. I think that's actually the wrong time. It's supposed to be 6 hours and 12 minutes later, but whatever. We measure the tide at 6 feet. So that's low tide. 12:30. And that's at 6 feet. So now we need the middle, so the midline of 6 and 13. That's just the average. 6 plus 13 is 19 divided by 2. It's 9.5. If the midline's 9.5 and high tide is 13, that means the amplitude, the change here, is 3.5. Now we know B, we know the midline, we know the amplitude, and we know the start time. That's everything. That's A, B, C, and D. Since it starts at the top at 6.3, that's positive cosine. We're going to write it out as a positive cosine. Amplitude first, 3.5. Then B, the period changer. X minus the phase shift, it shifts over to 6.3 to the right, so it's minus. Plus the midline, which is right here, 9.5. So there's our equation. So we're going to type that into our calculator and get the approximate depth at 2 a.m. 2 a.m. is going to be x equals 2. 11 p.m., you got to think about this kind of like military time. It's going to be 12 plus 11. It's going to be 20. X equals 23. So those are going to be our two values we plug in to get the height. Back to our graph. We've got our equation. Whoa. 3.5. Put parentheses around your fraction here. Just prevent issues. And then another parentheses around our x minus 6.3. Close that one and close the entire parentheses that goes around the cosine function plus the 9.5 at the end. So that second parenthesis is like our bracket right there. So there's our equation. We're going to draw it. We got to check our settings and our window on this. So since this is pi over 6.2, since we talked about a period of 2 pi, that's radians. If we would have done degrees of period of 360, then that would have been degrees, but we did radians. So make sure your calculator is in radians. Now we got to set up our window. Our x value is time. We're talking about 1 whole day, so time would go from 0 to 24 because we said it's like military time. And then our y values from our little graph that we sketched, we know it goes down to at least 6 and up to at least 13. You can go further than that. You can do like 0 to 20 if you wanted to, or whatever you want them to be, as long as you include a minimum of 6 and a maximum of 13 or higher. I like to go a little bit more because otherwise we don't have any margin on our screen and it's hard to see stuff. So that's what the tide looks like. Starts out midnight, around midnight, it's close to low tide, goes up, down, up, back to low tide-ish. So approximate depth of the water at x equals 2. So that's a G-solve y-calc, x equals 2. The depth's 7.5 feet. And then again, x equals 23 this time. $7.5 feet. Interesting. Yeah, nope, that was, yep. Just kind of weird. Then second part, or part C, says, what's the first time that day that the water's at 8.5 feet deep? So 2 ways to do it. You can draw another horizontal line here at y equals 8.5 and calculate the intersection, or you can do an x calc with the y value of 8.5. And that's the first one. If it said the second time that it's at 8.5, you'd have to scroll over. But the first time is right there at 2.628. Now, that is supposed to be a time. 2.628 o'clock is not a time. So we need to convert that. We know 2 is going to be like 2 a.m. But we need the 0.628 portion of this. With the cursor of on your graph still at 2.628 there, go back to the main portion of your calculator. You hit X, it's going to keep that number for you. Like we said, we don't care about the 2, so subtract the 2 away from that. We just want that decimal. And then to figure out how many minutes that is, we got to convert. That's hours, we're going to minutes. We got to multiply by 60. So it's like 37.7 minutes. So it happens when the clock is going to say 2:37. Yes, you would round that to 2:38, but the clock will still read 2:37.